All right. Hope it's recording. Today's lesson is 5.2 day 7 sex linked traits. So, we've been talking about different traits being passed down from parent to offspring. When this is saying sex linked traits here, it's talking about like gender, male or female. It's not talking about like other stuff.
Yeah.
All right. Good. Just in case, just in case. What is hemophilia? Do some research. Yep. Hemophilia. Clot. Exactly. Hemophilia causes blood not to clot properly. They have the causes to not clot properly. Yeah. That's much good. Because it's research. All right, your objective is to explain how sex-linked traits are passed down from parents to offspring. Well, here's a good. Why the long face? Ready? And then mom with red hair passes down the red hair. The dad with the straight eyebrows. Straight eyebrows. Oh yeah, red eye. And maybe he passes down the haircut too. Probably not. Yeah. Like father, like it does seem like boys often look more like their father and girls look more like their mother, but not always. Sometimes it's opposite. See, sometimes it's feeling good. Oh yeah, that's that. All right. Here's some text from the book Vital Genes. The body cells of humans contain 46 chromosomes that form 23 pairs. Chromosomes are made up of many genes joined like beads on a string. Although you only have 23 pairs of chromosomes, your body cells contain between 20,000 and 25,000 genes. So there's like about 1,000 genes on each chromosome. Pretty much what you're saying, more or less. All right, a pair of chromosomes. Chromosomes in a pair may have different alleles for some genes and same allele for others. So look at this chromosome here. This is a pair of chromosomes, and here's a gene. Each little section is a gene, like an allele. So look at this. This one's heterozygous. So it has a capital A and lowercase a. And so inside your body in the genes is not a capital A, lowercase a, whatever. There's a dominant allele and a recessive allele. And again, the capital will be dominant, the lowercase will be the recessive one. This one's homozygous, so they're both the same. What one would this be? Capital C, lowercase c. Homozygous or heterozygous? It's a capital and a lowercase. Is that homozygous or heterozygous? Heterozygous, good. Lowercase c, capital Z. Homozygous or heterozygous? Good. Capital, capital. Capital F, capital F. Lowercase g, capital G. All right, perfect. See you guys, Spencer. All right, what are the functions of the sex chromosome? The body cells of humans contain 23 chromosome pairs of 46 chromosomes. The sex chromosomes are one of the 23 pairs of chromosomes in each body cell. The sex chromosomes carry genes that determine a person's sex as being either male or female. They also carry genes that determine other traits. Girl or boy, the sex chromosomes are the only chromosome pairs that do not always match. Girls have two sex chromosomes that match. The two chromosomes that are called X chromosome. Boys have two sex chromosomes that do not match. They have an X chromosome and a Y chromosome. The Y chromosome, yeah, it actually is a different. The Y chromosome is much smaller than the X chromosome. To show the size difference in the sex chromosome, figure 3 have been stained and magnified. Hopefully, oh yeah, see, look how big the X chromosome is. You know, eensy beensy the Y is. So small. Girl have two X's, boys with XY. So this would be a boy.
Anyways, I meant their eggs.
We're gonna look and see and do a. Oh, look at this. Females have the sex chromosome XX, and males have the sex chromosome XY. Yeah, I think Joe said it right.
The eggs themselves don't have gender.
I think it's the males that determine it. But we're gonna look at a Punnett square in a minute here. Tell us the percentages of each. All right, so here's a note to take. Females XX, males XY. So there'd be a quiz and or test question where it shows a picture just like this. And you have to determine whether it's a boy or a girl. It'll have either XY or XX. So as long as you're paying attention right now, it won't be hard to do whenever you're taking a quiz or test.
How people find out what their baby's on?
No, yeah, like it's called like a sonogram. You can see a little bit. Yeah, exactly. We'll do that in a minute. So they can tell in the X-ray sometimes. Sometimes they get confused with the belly button, but you know. I guess it's the umbilical cord at that point. All right, so yeah, here's a Punnett square. And you're gonna do this the same way you do Punnett squares. And then remember, if it's an XX, label that box female. If it's XY, label that box male. And you'll label it on the second line. No, not quite, Joe. So this one, for example, would be XX. Then the second line, you'd label it male or female. All right, how to do this? Oh, good. All right, so what will be the genotype in the top left corner? Yeah, exactly. And then what's the phenotype in the top left corner? Female, yeah. All right, I don't know which one's next. I think it's this one. What's the genotype top right? And then the phenotype? Yeah, exactly. Bottom left?
Female.
And female. Bottom right? And XY. So what this is saying is an offspring is a 50% chance of it being female, and 50% chance of it being a male. Perfect, huh? That works out really well in life. You want to have about the same amount of boys and girls in a pool of animals. Doesn't that make sense? Apparently, I think there's more boys that die younger than girls. So by the time you're up to like age like 20 or something, there's more females than males. So I guess.
No, I don't think about old. Old. Mostly girls that live.
Yeah.
You ever see that? You know what it is? It was like the longest person to live was like 16 years. Yeah, and it was a girl. There's never been a girl.
He says 124. I don't know. But yeah, women tend to live longer than men for many reasons. All right. Let me read this. Like other genes, sexual genes have a dominant and recessive allele. In females, a dominant allele on the X chromosome will match the recessive on the X chromosome. But in males, there's usually no matching allele on the Y chromosome to match the allele on the X chromosome. As a result, any allele on the X chromosome, even a recessive allele, produce a trait in the male who inherits it. This means that males are more likely than females to express a sex-linked trait that is controlled by a recessive allele. Individuals with color blindness may have difficulty seeing the number in figure 5. test your vision. Below, can you guys read both of these?
Why?
Yeah. 24, I mean 74.
Yeah, 12 to 74. And so that's why boys are more likely to be colorblind than girls, because the XX in girls is like stronger and more stable, and you're less likely to have the recessive allele.
Yeah.
And that happens in colorblindness, hemophilia. Remember the first question we talked about was hemophilia, the warm-up, where your blood doesn't clot, where you just bleed a lot. And there's a few more. All right, because these disorders are recessive, males are more likely to have them than females, because males only have one X chromosome. Bless you. Ben says 1274. What does that mean, Ben? 1274. Slide 12. We're on slide 12. Good job, Ben. All right, y'all ready to move on? Perfect. Color blindness. Inheritance of color blindness. Color blindness is a trait controlled by a recessive allele on the X chromosome. Many more males than females have red-green color blindness. You can understand why this is the case by examining the Punnett square in figure 6. I don't know if I have that here. Oh yeah, see this one here. Both parents have normal color vision. Notice that the mother carries the dominant allele for normal vision, X to the capital C. The recessive allele for color blindness, X to the lowercase c. A carrier is a person who has one recessive allele for a trait and one dominant allele. I think we've already learned this before. Do you guys remember that? A carrier has a trait controlled by a recessive allele, does not express the traits. However, the carrier can pass the recessive allele onto his or her offspring. In the case of sex-linked traits, only females can be carriers because they are the only ones who can carry two alleles for the trait. So, do I ask you guys to fill this out?
Wait, which slide is it?
I don't think it's on or not.
Slide 11, 18.
14. No, but we'll do one in a little bit. Who is this? Oh yeah, hi Don.
Memorize everyone's profile picture.
That's funny. Probably from all the Google Meets when they were virtual. All right, so here's a father with normal vision and a mother who is a carrier. Do I have that filled out? So they'll have a chance of having a female with normal vision and a female who's a carrier, because this is going to be X to the capital C, X to the lowercase c. And I should get this app open here so I can write on the board. Yeah. We'll fill out one of these similar to it in just a minute or two. But I'm going to get this open now. See if I was prepared. If I was a good teacher. I already had this open. All right, so this one will be X to the capital C, X to the lowercase c, X to the capital C, Y, X to the lowercase c, Y. And see, now this person is going to be colorblind, a colorblind male, because there's no dominant capital C. So it'd be much less likely for the female to be colorblind. It'd have to have a colorblind dad and a mother who was a carrier in order for the offspring to be colorblind. So it's pretty rare. Yeah, if both your parents were. All right, a carrier is a person who has one recessive allele for a trait and one dominant allele. In the case of sex-linked traits, only females can be carriers. All right, now Benton says nothing. Hi, Benton. Oh, Benjamin Dunn had a really good yellow and blue fish last week. Do I still have it?
Is his still on that page?
No, that was Austin Perot. He's actually on here right now.
Of course, Austin Farley is in there.
Oh, Austin's a good kid. I can't find it.
And Joe's goal was to be Austin and Joseph.
Yeah, Austin.
Hey, you got high place.
He's really smart.
Austin's a good kid.
Yeah, he's on here right now.
Hey, Austin.
All right, let's keep going here. Sex-linked genes. The genes for some human traits are carried on the sex chromosome. Genes found in the X and Y chromosomes are often called sex-linked genes because their alleles are passed from parent to child on sex chromosomes. Traits controlled by sex-linked genes are called sex-linked traits. One sex-linked trait is the red-green colorblindness. A person with this trait cannot see the difference between red and green. Normal vision is dominant, while colorblindness is recessive. So here's the Y chromosome and X chromosome. Recall that the Y chromosome is smaller than the X chromosome. Females have 2 X chromosomes, but males have 1 X and 1 Y. These chromosomes have different genes. Most of the genes on the X chromosome are not on the Y chromosome. So an allele on an X chromosome may have no corresponding allele on the Y chromosome. Interesting. All right, here's a couple more notes. Sex-linked disorders, genetic disorders carried on the X chromosome. Sex-linked traits, traits carried on the X chromosome. Uh-huh. Huh? What? I didn't hear what you said. I don't know. I bet so. Yeah. Sometimes babies will be born with a full head of hair, and they'll lose it after a few weeks.
Sometimes they'll be blind.
Yeah. All right. Could you guys tell me, is this person male or female? On the right here, all the genes, all 23 of them, are one person. This is a male because it has XY. All right, examples. So if hemophilia is a sex-linked trait, cross a normal male with a female who is a carrier for hemophilia. So let's see what it looks like on your end here. I don't know. X chromosome. All right. So I already set it up for you all, and it was if hemophilia is a sex-linked trait, cross a normal male with a female who is a carrier for hemophilia. So the normal male has X to the capital H and then Y. So the capital H is not colorblind, it's dominant. The female is a carrier, so she's got 1 X to the capital H and 1 X to the lowercase h. All right, so on your document, this can be kind of tricky to type in, but you guys can do it. So how do you do it? Let me zoom in here.
What do you do to control it?
Yeah, exactly. It's easy to do. So this one is going to be what? What's you got type? So I type in X, the control period, capital H, control period again, X, control period, capital H. Or like Joe said, copy and paste.
I just copied and pasted because I didn't know about the control period.
So it will be faster, I think, if I copy and paste this here, and then I can just change that one.
That'll be just easier for me to learn.
All right, and then, oh, I did this one for you all. What should be the genotype of the offspring in the bottom right corner?
Lowercase a Y.
Perfect. Yep, exactly. All right, let me see here. Yeah, and do I ask you the percentages? No. So the percentages for this one here are 25% normal female, 25% normal male, 25% carrier female, and 25% male with hemophilia. So if the mother is a carrier for color blindness, there's a 25% chance the offspring will be colorblind male.
Or happens to.
Oh, this one's hemophilia. Okay, good point. Yeah, so this was the mother, the carrier for hemophilia. So 25% of the offspring will be a hemophiliac. All right, question 2. If hemophilia is a sex-linked trait, cross a male hemophilia with a female who does not have hemophilia. All right, I set this one up for you all. So the male is X to lowercase h, Y. The female is both X with capital H, X with capital H. Yeah. No, the lowercase is hemophilia. Yeah, because it's recessive. So if there's a dominant, a capital H, then the person won't have it. If it's a male with a lowercase h or a female with two lowercase h's, then the female will, or they'll have it. Does that make any sense? If it has a capital at all, they won't have hemophilia. So they have to have either two lowercase h's. So this would be a female with hemophilia. This would be a male with hemophilia.
I'm talking about.
All right, so the second one, Joe says that nobody has hemophilia. And I think he's correct. The top left is X to the capital H, X to the lowercase h. Top right, X to the capital H, Y. Bottom right's the same. And the bottom left is the same as the top left. Yeah, so here there's a 0% chance of hemophilia. And is that what I say on the thing? Yeah, but you still have 50% of females be carriers, though. So they could pass it on. All right. Let's keep going. You guys are doing great. Let me fix this before I forget, though. Anything else? No. All right, so thinking, can a woman who does not at least carry the hemophilia allele have a child with hemophilia? Why or why not? Yeah. Because it's thinking. Anybody have any thoughts on this?
Yeah, it's the dad.
Why do you think not?
I don't think it's the woman.
Yeah, because if the female has is double X or capital X, capital H, capital X, capital H, then none of the offspring were on this one. So here's what my answer was on the slide. No, because if the baby gets the X chromosome from the father, it would be a girl. I'm not sure that actually makes a lot of sense.
From the father? It will be a girl. What is that? Oh. Okay.
Yeah, I'm not sure that's a very good answer, though. I like looking at this thing a little better. The female, you know, it's going to always pass on a dominant allele for no, the mother will, sorry about that, people, always pass on a dominant allele for no homo or hemophilia. I think I put the answer in last year and I was
wrong.
You want us to put that in instead?
Yeah, this is a better answer for sure.
I'm gonna put my own answer that's basically that.
Yes, absolutely. Good question, Joseph.
I have to answer in memory.
Mhm. All right.
It's more likely for a male to get hemophilia and that have human.
I guess so. I never thought of it like that, but you're absolutely right, Joe. All right, let's go on then. You guys are doing great here. Oh my gosh, we're almost done. This is fantastic.
If it was called hemophilia.
Nice. I see what you did there. All right, wrap up. How are sex-linked traits different than regular traits we've been studying so far?
I got to stick to the bottom.
Nobody knows. How are sex-linked traits different than the regular traits we've been studying so far? I don't love my answer key for this either. There is an optional extension if you like. It's not too hard.
Do you like take like a field trip for high school too?
I don't know. Probably not with COVID.
Tour like we did for like 3 hours. Like you know how like in like fourth grade and like fifth grade, while they're in school, yeah, they're like high school, but you know like college. I don't know what's familiar with that. I'm for one. I know we would. Okay.
It was me.
All right. That concludes the recording. If you have any questions, email your teacher.